Today we are going to be looking at bivariate data still, but we're going to be talking about the correlation coefficient and future predictions. So I'm kind of doing this a little bit differently so that you can see some of the computer pieces as well. But the first piece that we want to talk about is how we can do some future predictions. So if we go back and we look at our data from page 28 in our notes, where we were looking at writing an equation of the best fit line based on the number of days that you're absent and the score that you would get on your exams. We came up with the equation y equals negative 3.4. Sorry, decimals are really hard on this. X plus 90.2. Right? We said that was our equation. Decimals are really difficult. There's decimal there. Okay, and we said that we could use we are now saying that we can use this to make predictions on how other students might do on their exams. So, for example, if we have another student, if Andrea is absent for 9 days in the trimester, what might we predict her average score on the exams would be? Okay, and what this is telling us is if we can identify a new X value, we can then take that value and plug it into X in the equation we had. So now instead of saying negative 3.4 times X, we're now going to say negative 3.4 times 9 plus 90.2. And again, you can use a calculator. You can use whatever you would like. Okay, times 9 plus 90.2. And we get out an answer of 59.6. So our prediction would be that if Andrea misses 9 days of school in the trimester, her exam would be 59.6%. We can then use this for multiple situations, for multiple different people, in any different way that we want. So if Luca was absent for 8 days, what could we predict? So we'll do the exact same thing. We'll take that same thing, but now instead of saying negative 3.4 times X, we'll say negative 3.4 times 8 plus 90.2. Okay, and again, we can use a calculator to do that. And if we plug this in, this will give us an output of 63%. So we would predict Luca would get a 63. We can also do this in reverse order. So if Hugo scored a 64 on his exams, how many days might we predict that he was absent? Now, this is now talking about his exams. His exams is a Y value. The exam score is the output value. So we would want to be plugging in that 64 for the Y value. So we would now say instead of Y equals negative 3.4 times X plus 90.2, we'll say 64 equals negative 3.4X plus 90.2. But we'll want to solve this. It's a little bit difficult for me to write as small on my tablet, so I might have to go over some of the other words, but you can probably fit it. So we'll undo addition with subtraction. Right, so we're going to do 64 minus that 90.2, which will give us a negative 26.2, right? These cancel. And then we'll undo multiplication with division. Okay, so we'll do that negative 26.2 divided by that negative 3.4. These cancel. And we get about 7.7 days. Now, can you be absent fractions of a day? Yeah, I mean, you could leave for a doctor's appointment. So whether we say 7.7 or about 8 days might depend on how specific we want to get. Now, how realistic are these predictions? Are there other factors we might need to consider? I mean, yes, you could be present every day at school, but never pay attention and never do any of your assignments, and then you might not score well, right? The only factor here is not whether or not you're absent. Okay, but there is a mathematical thing that we can do that helps us determine how reliable those results are. And that is called a correlation coefficient. It is a big fancy formula. Okay, it is not something we would ever expect for you to be able to do on your own. But this formula allows us to calculate this value, the correlation coefficient. Okay, it's a mathematically calculated value that tells us how strong a relationship is between the two things. The value that we get out will always be between 1 and -1. So no 2s, no 2.1s, always in between 1 and -1. Okay, the closer the value is to 1, the stronger the relationship is, and it will be positive, uphill. So if we have a perfect +1, we will have a perfect upwards line. Now, it could be at any angle, but it is going upwards and they will be a perfect line. Now, 0.8, right, is still close to 1. So our data is all sort of falling in here. That's sort of what we've been looking at. Doesn't make a straight line, but in general, we see a trend. And the further we get away from that, then the more sort of chaos and sporadic our points get. Okay, likewise, the closer we are to -1, then the more downhill the trend is. So if we're at exactly -1, we're perfectly downhill. Again, that could be at any angle, but it'll be a perfect line. Right? -0.8, we have a little bit more distance in between those points, but we still see the general trend. And then the further and further we get away from that, the closer we get to 0, okay, the more sporadic, until we do actually get to, we're right sort of in the middle, and there's nothing here. We don't see anything going uphill, downhill. There are just points all over the place. There doesn't seem to be any trend at all. There's just no correlation. Now, to calculate that correlation coefficient, we do this in Desmos. So I gave you really fancy steps that you have that show pictures and everything in between. So underneath these tables, you just see a quick snapshot of those steps, but you can flip to that previous page in your notebook that we already put in that has all the very specific details with pictures included. Okay, what I'm going to do is I'm going to open up Desmos, okay, but I am going to make it so that half of my screen is Desmos and half of my screen is the table that we are looking at. Okay, so I'm going to open up my Desmos over here. Okay, so I can still see the data that I need to enter, but I can also work over here on my info as well. So if we want to calculate the correlation coefficient, we're going to go to Desmos, right? When you first go to Desmos, you're still going to have to click on your graphing calculator. Okay, and then your upper left-hand corner, you're going to click this plus sign. And when you click it, it's going to give you an option of what you would like to add. And we are going to add a table. And then we're simply going to type in the data that's given to us. I think it's easiest to go down the left-hand side because if you just hit enter, it will go down. So I'm going to do 22, 16, 35, 62, 60, 30, 48, 52. And then I'll go back up and then I'll do the right-hand side. You don't have to do it in this order. You just need to get it all typed in. This is just what I find is easiest for me. These are just random data points. We don't know what they're associated with. That's not important right now. Uh-oh, I missed a point. Okay, so look, when I'm here, my numbers don't match up, which means I missed a point or I typed an extra in. And if you look, I accidentally typed 79 twice, right? So I got to make sure I get these all lined up and I have everything matched up accordingly. Okay, even typing one number wrong is going to give you the incorrect data. Okay, then once we do that, we're going to go down underneath here and we're going to go into a new box. And in this box, we want to type in that formula that you see. It's basically y equals mx plus b. Okay, it's this one here. Now, we can't see what's going on with our data because our data is bigger than here. So you can scroll around if you want to see exactly what's going on. You can click on the wrench, which is right here. Which is right here, and adjust your windows by changing your X values to be in between your X column. Usually my students just sort of prefer to scroll. They know where they're looking. Okay, and we're going to type in Y1. Now, we want that sub 1, but when we type the 1, it just makes it that. So you don't have to do anything special. And then you want your little like squiggly. It's shift and then the button next to your 1. MX1, again, when I just type X followed by 1, it does it, plus B. And you'll notice it puts in sort of a line here, but it spits out these values. And this R value right here is your correlation coefficient, not your R squared, just the R. So that tells us over here, when we're looking at this, that our value right here is going to be 0.9599. This is really close to 1, which means we should see a pretty darn stinking straight line. And that's exactly what we see. Okay, so you go through doing that exact same process and calculate the correlation coefficient for the remaining 2.